Ok, vamos a chequear la asistencia entonces. Y bueno, espero que se hayan podido pues, relajar un poquito aunque sea y estemos atentos entonces, por favor, si no pueden decir presente, deben escribirlo en el chat, ¿verdad? Perfectamente se entiende. Empezamos entonces. Lourdes.
Here.
Lourdes. Okay,
Here.
there you are. Nice. Kaylin.
I'm here.
There you are, Kaylin. Let's go with Mayra. Mayra. Ok, permítanme. Creo que quieren agregarse. Cuando tengamos estos breaks así, porque mañana en la clase vamos a tener uno, no es necesario que se desconecten, ¿verdad? Pueden dejarlo ahí habilitado, igual van a dejar creo que su computadora encendida, así que no es necesario que se desconecten. Ok, Jenny. Jenny Teruel.
Presente.
Yajaira.
Presente.
Marcela.
Here.
Ana Ruth. Ana Ruth. Ok. Ana Lucía.
Presente.
And we go with Flavio. Flavio no se conecta. Ok. Mariana.
Presente.
Sara.
I'm here.
There you are. Ariel. Ariel. Ok, Ariel tuvo que desconectarse, ¿verdad? Ok. Aurora. Emily. Emily.
I'm here. I'm here.
Ana Gabriela.
Presente.
Jennifer. Jennifer Fabiola.
Presente.
Diana Marisela.
Here.
Cintia Pamela Vallecillo.
Presente.
Trixie.
Present.
Está Trixie. Olga. ¿Conocen ustedes a la compañera Olga? Porque no se ha agregado al Classroom. ¿Alguien la conoce? Nadie la conoce. Ok. Tiffany.
I'm here.
Okay. And we go with Mauricio.
Here, mister.
There you are, sir. Okay. So,
Falto yo, no me mencionó.
excuse me, who? ¿A quién? ¿No mencionó?
Mayra Soler.
Ah, no, sí la mencioné, pero no estaba, se conectó despuesito.
No, es
Bueno.
que se me desconectó mi Zoom.
Ah, bueno, entonces no estaba, se desconectó y se conectó despuesito.
Ok.
Ok. Bueno, perfecto. ¿Alguien más que nos haya llamado? Porque sí, la asistencia es importante. Ana Ruth. Vuelvo a llamar a quienes no me contestaron. Flavio. Ariel. Aurora. Y Olga. Bueno, preguntaba si alguien conocía a Olga, por si, no sé, Mayra tal vez la conoce. ¿No? Ok.
No.
Vamos a ver cómo nos comunicamos con ella.
Había una compañera que se llamaba Olga Savillón, no sé si es ella. Ella estuvo y después se tuvo que salir en la clase pasada de psicología.
De veras, pero sí,
Filosofía.
Olga Savillón Urbina. Sí.
De filosofía, sí. Entonces, yo iba a trabajar con ella en un grupo, pero al parecer no le valieron equivalencias, algo así.
Ah,
No sé si será por eso.
sí, de repente. De repente. Bueno, pues vamos a consultar por ella, pero igual cualquier cosa, si ustedes saben algo, por favor me notifican porque, bueno, en esta situación es bien complicado a veces, si no se sabe un poquito de los compañeros, saber algo de los demás, ¿verdad? Pero bueno, igual tenemos que estar atentos por el compañerismo y además de que en algún que otro momento, de repente esa persona vaya a ser nuestro compañero, ¿verdad? En el compañero de trabajo o compañera de trabajo. Okay. So I think we're ready to continue, and I think we have enough time to talk about the step numbers operations.
Mister,
Want to say something? Sorry. No. Okay, here we go, and we stay with this part of the real number. Interesting question, the one of Mauricio about the negative and the positive infinite. Those are included in the real numbers. Do not think that this closed shape means that this ends. No, and it's something we're going to talk about right now.
Mr.
Yes? Yes, sir? Yo creo, no sé si es que se le entrecorta o quiere decir algo y no le escuchamos. Mauricio creo que estaba hablando, ¿no? Okay.
No, Mr. No, Mr. Thank you. Excuse me.
Okay.
Sorry.
Okay, don't worry. So here we stay, o no sé quién está hablando, pero bueno. And that's practically what we have and what we teach, okay? Based on those numbers, we teach all the mathematics in the elementary, okay? Starting with natural numbers, going then to rational numbers, and I don't know why in the NCTM, for example, have been a little discussion, but this was like 20 years ago, of why do not let the responsibility to talk about negative numbers in early years. Well, that's another topic, but the main conclusion is that students supposed to not be prepared. Well, I don't know, but today those children surprise me a lot, okay? They investigate things on YouTube or on Google very quickly. It's an advantage they have, like the education we receive, I think so, okay? So focusing on this, let's talk about now the set theory, okay? The set theory of numbers. We have been talking about some set of numbers, but what is a set of numbers at the end? It's a collection of elements. It could be, in this case, a collection of numbers, okay? If it's a set of numbers. But in general, if I say a set, it's a collection that doesn't accept repetitions, okay? We're gonna say something about it. Concluding and connecting the topic of the real numbers, of the set of the real numbers with the set in mathematics, the set of the real numbers is considered as the universe, something we already say. So for the mathematics you're going to teach, the real numbers are like the universe. It doesn't exist something else more than this in the mathematics that we teach in elementary, okay? Each of the kind of numbers described makes a set with some important relationship that work for this set and probably will work for the other ones, okay? If you know, the other sets start getting like the properties the other one works. So the number sets we know, natural numbers represent with a letter N. Integer numbers doesn't represent with the letter I, it represents with the letter C. Who knows why? Who knows why? We use letter Z to represent integers. Okay, if you can Google it. Rational numbers represent with the letter Q. Okay, I know the answer for this one. And Q is of quotient. So that's why I represent this one as rational numbers. Because at the end, write a number over another is represent a division, and the result of this is called quotient. That's the main reason. And the other real, the other real numbers we have are the irrational numbers, which are like the counterpart of the rational numbers. And finally, together, the rational and the irrational makes the real. Did anyone find why the integer numbers receive the letter Z?
Yes, I found it. It says that it comes from the German word Zahlen, which means
Zahlen.
numbers. Zahlen. Mhm.
Zahlen. No, honestly, I don't know German, but I hear the pronunciation. I Google it too, and it's like Zahlen. I don't know why those people shout when they speak. That's the rule they use, okay? But it's true. That's why, okay? Which means numbers, you say, right, Anna?
Yes, that German word means numbers.
Excellent, Anna, and it's true. It's like the main idea, okay? And everything has an origin. The origin of that letter Z comes from the German Zahlen or Zahlen. Is Z-H-A-L-E-N, right? Like that, Zahlen. If
Yes.
you want, Google it. So
Yes.
So in
it's-
mathematics, oh, sorry, want to say something, Mayra?
No. Nothing.
I was thinking that you know some German and you're gonna tell us like the pronunciation.
No, I just want to say that you are spelling the word correctly. Just that.
Okay. Oh, you Google it too. That's nice. So a set of number, and I think someone sent. Oh yes, you send it over there. Oh, I said the letter H in the wrong way, but I think you have the word over there. So a set of number at the end is a collection of real numbers, but without repetition. So in a set of number, you cannot say that you have the one, then the 2, the 3, the 4, the 5, the 3.5. No, you cannot repeat values over there. The values receive a unique moment, okay? It cannot be repeated. Something about the notation, they are calling capital letters. They can be represented in different notations. And this is the first part we will study, okay? I hope that you get like the notation to represent those numbers. The set builder notation is one of the interesting ones, and honestly, one of the most used in those algebra books. The number line, I think, is one of the most common too, but not too much as the set builder notation. But the most common way to represent a set of numbers is the interval notation. Those ideas of set builder notation, those ways to represent the set in mathematics, especially the interval notation, will be useful for students to build the idea of function, which is one important structure of the algebra. And of course, it's something the students will study in the high school, okay? But it's something that if you talk about number line, and I think you do it, you must be careful about how you teach it. Like consider the part I told you. Of course, you probably don't work with the negative part. It's just like a blank, or probably you start with 0 and then going on. But it's very interesting, okay? The set in mathematics. So here we have little examples of this one. The set builder notation use algebra to represent these numbers, okay? And in general, for example, if you say a number greater than or equal to 2, well, you're talking about how many numbers are greater than or equal to 2. And one observation, every time that I say number, think in real numbers. So how many numbers are greater than 2? Exactly, there's no answer for this question. Okay, Rixie, you want to say something?
What's the question you say? Because an answer like infinite numbers came to my mind, but I don't know.
Yes, I mean, it doesn't have an exactly answer, an exactly quantity. What we say is that, well, there are many, just like that, it's okay, there are many, and it tends to be the infinite. The amount of answers you expect from there becomes to be the infinite. Look, I say just the numbers greater than 2. What happens if I say focus now just in the numbers between 2 and 5? Do we have a specific amount of numbers over there?
Yes, we have
Yes.
number.
Yes, we do.
Okay, but in what numbers you're thinking right now?
Numbers
3
2.
and 4. 3, 4.
4.
Okay, remember, every time I say number, think in real numbers. Because if you're thinking just 3 and 4 are the numbers between 2 and 5, hey, what happened with 2.5?
Would be
What happened?
2.5, 3.5.
But
Okay,
then
what
we would
happened?
need to count 2.1, 2.2 to like all of them.
So how many numbers are there? I think you get the idea.
Infinite number.
There are
infinite
infinite
real numbers.
amounts. There are infinite real
real
numbers. Just listen, just between 0 and 1, there are infinite numbers. And how can we represent that infinite numbers, infinite amount of numbers? I mean, look here, it's like 0.5, here is like 0.25, here is like 0.125, here is like 0.600, 12 and well, I can get closer and closer to 0 or being closer as much as I can, like 0.90, 0.99, 0.999, and being closer to 1, but there's always a number between those. Okay, this is called the density problem, sorry, the density property of the real numbers. That every time you have two real numbers, there's gonna be a number between them, okay? So the main idea here is a set in mathematics can represent amounts that never end, and that's so interesting. Probably this was the question that Mauricio had, and about how can we represent positive and negative infinite with this notation, okay? So that's the idea here with the set in mathematics, and that's what we will do. Honestly, for example, here with this exercise you're having over there, like x greater than 2, in the number 9, as you can see, this like line segment going to the, well, it's not a line segment, it looks more like array going from 2 and goes on. And here another notation like this bracket and then a parenthesis and the infinite sign over there. It's about this, okay? It's a way to represent all those real numbers that just between 0 and 1 that are infinite numbers. So from 2 to the infinite, come on, are infinite numbers too. So this idea it's something that you can do just in mathematics, okay? Because again, the numbers are just ideas, and how can we represent that amount of, well, it's not an amount of numbers, all those numbers that are there with the set notations we have in here, okay? It could be with the set notation, set builder notation, it could be with the number line, it could be with the interval notation. We're gonna see some examples of those, but wanna tell you first of all, the theory that works behind that. To build a set of numbers, you can create mathematical rules, okay? And you have some special elements to consider. For example, the set of all even numbers. You were saying this at the beginning. Yes, it's a subset of the natural numbers. For example, you can say that just by x such that, sorry, pronunciation is such that little line is written like x such that x, the natural numbers that behaves like this, the double of a numbers. All those are even numbers. I'm sure that if I gave any natural number here, and I'm specifying, look, I'm specifying that I'm talking about natural numbers. And if I double any natural number, then I'm gonna have an even number. Thinking any natural number, even in odd numbers like 3. But if I double 3, then I got 6, and 6 becomes an even number. So those are like general ways to talk about those numbers. So and instead of say all the even numbers, I can say the numbers that behave like 2x. Understanding x as a natural number, okay? Something interesting is that we have non-common ideas to represent the set of numbers. One of those is the roster notation. Not too common to use it because sometimes like for exercise or for sets that have like, that doesn't have an end to the left and doesn't have an end to the right, it's so hard to make this understandable or something we can see differently than with other notations. So it's not a notation that we're gonna focus on. It's better to work the set builder notation. The number line notation, here you have the number line. I think you know how this one works. Common errors people do here, forget like there is an arrow that tells this goes to the infinite, another arrow that tells this continues growing and growing and growing. And of course, this is to represent real numbers, okay? That's the main idea. We're gonna use those sets of numbers, or this set in mathematics, to represent real numbers. Okay. Moving on next, we have the set operations. Of course, we're gonna see these in practical. We're gonna see it in an open board, okay? So don't worry right now. I just want to tell you the theory first, and then we go to the practical part. So there are some set operations: the union, the intersection, the difference, the complement, and there is one more, which is like a kind of complement of a complement, and the empty set property. But we will not study those right now because we just care about the real numbers. The other ones will probably work for other ones, for other sets, and especially like the examples I will show you. So there you have the notation of each one, a letter U for the union, and a special an upside down letter U for the intersection, a minus sign for the difference, and like an A to the power of C for the complement. We'll explain you each of these ones, starting with the union. As you can see here, you have two sets of shapes. Don't know if you remember the name of those shapes. For example, the shapes for the set A. Can you tell me what is the name of these shapes? What are the names?
Pentagon. I think.
Pentagon?
Solid.
Rom-
And rhombus.
Rhombus.
Square and
Square.
rectangle.
And rectangle. Okay. Then here we have a triangle,
Triangle,
and a star, and a
and a
pentagon.
pentagon.
Okay, you got it. So the union will consider the union of those sets. And look, I'm not working numbers right now. I'm working shapes. That way you're gonna get the idea quickly. I think so. I hope so. The union will work the elements in A, but at the same time, the elements in B, not repeating those values. For example, pentagon and pentagon repeats in A and B, but at the moment to consider the union, I just get it one. So the union is the easiest way to understand the set of numbers or the set, this operation set. I mean, you're gonna make the you're gonna join, I mean, two sets, and that way you're gonna create a new one. A good example of this, the union of the rational and the irrational numbers, which makes the real numbers. Okay, so here you have it. And don't forget that you will never repeat elements in here. Okay, we go with the next operation. The next operation is the intersection. Intersection consider common elements of A and the common elements of B, but not repeating the sets, the elements in the set. So you create a new set of just common things. Set A, pentagon, rhombus, square, and rectangle. Set B, star, square, triangle, and pentagon. If you see, you have repeated the pentagon and the square. No else. That's why the intersection just becomes like common things. Those are basic operations. Let's see one more, and it's a little interesting. The one that is called the difference. And as you say it in your forum number 1, the community property for difference doesn't work. It doesn't mean that the community property for intersection works or the community property for union works. Well, it's not the point right now, but essentially here that you have a subtraction, it will not work. I mean, A over A minus B doesn't mean the same as B minus A. So be careful with this. Are the elements of A that are not in B? This is one way to understand this one. For example, in these two sets that we have, the elements of A that are not in B, for example, this one is in B, this one is in common. What else is in common? The pentagon is in common. So immediately I know that A minus B will be just this one and this one. Like the missing part, if I like try to see what they have in common, it's like I eliminate the things they have in common, thinking that I'm taking out those values of B, okay? And at the end, this stays like that. So this is for A minus B, but what happens if I want to show B minus A? Okay, I'm gonna do like the same, but now thinking that I will consider the elements of B that are not in A. What are those? Okay, let's see. The elements of B that are not in A. For example, A have this one. What else? A have this one. If you see, yeah, I'm taking out like the common things. Essentially, it's like that. Take out the common things. And then the result will be the missing part of B, the rest of B. And essentially, that's why the parts of the subtraction, if you remember, the subtrahend, the minuend, and then the rest is because at the end, something is gonna be there. And as you can see here, you have a good representation for those. This is the same as A minus B, and this is the same as B minus A. Just that in the book that I find this information, they use this notation that use like a division symbol, but not too common to use this one. I think that's more like in Spain. So those are like the 3 operations that works with 2 sets. Okay, the union, the intersection, and the difference. Let's go with one more, and the next one is related with the complement. The complement is just complete what is missing to have the total. And for example, if the total right now are like those shapes, the rhombus, the rectangle, the trapezoid, the pentagon, the triangle, the square, and the star, and the set A is this one, the complement of these will be like what is missing to complete the whole group. If I told you right now, what is the complement of the irrational numbers? What is the complement of the irrational numbers? Because I already tell you something about the universe. Consider in real numbers. What is the universe in real numbers? Don't remember? Okay, the universe in real numbers are all the real numbers. And here I'm talking just one part of those real numbers. So what will be the complement of this one? Any idea?
The rationals.
The rationals, of course, because those together will make the real numbers. Sorry, I get lost. The real numbers. Okay, so this one and the rational numbers makes the universe of numbers. We say is the real number. Okay, so immediately the complement, what is missing to complete the real numbers, is the rational numbers. In the case of irrational, and vice versa, right? And vice versa. So do not forget that main idea. Okay, so here we have the rational, the set operations. And we're gonna focus now into see how those works in a practical exercises that we will try, okay? So here it is. Are common elements of A and B, but remember that you don't repeat the elements. Sorry, this is not the definition. The definition is like what is missing to complete the universe, okay? Is what is missing to complete the universe from where they come from. And of course, right now we are clear that our universe are the real numbers, okay? So we're gonna try some exercises in the open board. I don't know if you ever used this application before. It's very good, it's for free, and I think that if you don't use it for your classes, you're gonna see how this one works. Okay, so let's go, and we're gonna focus now in this set number notation, starting here. One thing we can do in these real numbers is that we can write very quickly this infinite, not amount, or this infinite tendency of numbers in a simple way. As an example in here, what will be the set of the numbers that are less than 4? Okay, here you have the set builder notation, which is one of the most used, but the most common is this one, which is called the interval notation, using parentheses and brackets. I will explain you how it works. And in the number line, which is I think the one you probably will be using, how can you represent numbers that are less than 4? In this case, not including the 4, and I'm gonna explain you what's the main difference of include and not, or not include the 4. And what numbers are less than their 4? Well, or the ones that goes to the left of this one. And I think that's why this symbol is working that way. So here you have, and this is the number line representation. This is the set builder representation. This is the interval representation. So there you have it. Okay, at the end, these are like 3 different ways to understand the thing. Of course, we're gonna use like the first one to see the operations, because at the end, that's what we wanna do, operations with set. And let's try one more, okay? So probably you're gonna have some questions. I'm gonna give a chance at the end when I end this explanation. You're gonna have then the chance to explore some of those, and probably you're gonna have time to explore the operations too, the union, the intersection, the difference in some exercises with set of numbers. Here you have another set. Let be the numbers between -2 and 4. Okay, in the number line, it's very easy, but something interesting happened is that 4 is including. Here, that 4 wasn't included. Why? Okay, because you're saying just less than. When is gonna be included? When you say less than or equal to, that means included. That's why here you have just a less than symbol. If you don't remember what is that, less than or equal to, talking about this one, okay? And yeah, in that moment, you say that you include the 4, here is not included. What means for real numbers? What this means for real numbers? That you can get closer to 4 very quickly with numbers like 3.9, 3.99, 3.999, adding more 9, but you will never get 4, okay, for this set. That's like the main idea. And something similar is happening here, just that here you are including the 4. What it means? It means that the set of numbers includes the 4, or you can say that 4 is part of this. What happened with -2? Okay, with -2, it's gonna happen something like happened with the 4, because I'm not saying that I'm including the -2, okay? So when I'm saying here, let be the numbers that are between -2 and 4. So this is the way to represent these numbers in the number line, okay, as you can see. And here you're saying that you will not include the 2, which means that if you want to get closer to -2, like with numbers like -1.9, -1.99, those will be part of this set, but not the 2. Here, you can get closer to 4, like with values like 3.99, the values that I show you here. But here, in a determined moment, you can say that the 4 is part of that set. Okay, those are like basic ideas we have to focus on. When the number is included, when is not. Well, let's see how can we write this one in the set builder notation. Always the set builder notation starts with this. X such that X, and this X is a real number. Okay, we're talking about real numbers here. And the way to represent between in mathematics, and in this case, in this specific context of set of numbers, is write the lowest value first, specify if it's included or not, and you're saying that your value you're gonna use will be greater than, or you're saying that -2 is lesser than the number you're gonna use. What number? Okay, those real numbers that you are representing just with that variable X. And at the same time, this X is gonna be lesser, listen to this, lesser or equal to 4. So this is the way to represent that notation or that interval in this case, or that set of numbers. It's an interval right now, okay? So you're saying here, the values that are greater than -2, but at the same time, the values that are lesser or equal to 4 at the same time with this variable expression, you have it on here. If not clear, then you're gonna have the chance to make questions, but that's the way to write it, okay? So the main idea right now is focusing when this is included, when it's not. Now for the interval notation, which is like the most common one, we're gonna use parentheses and brackets. Parentheses for the numbers we wanna show that are open, observation, infinites are always open. Infinites are not numbers, are tendencies, but we're gonna consider this one like something we wanna get, the infinite, not as a number, right? And the way to represent when something is close with the interval notation is use brackets, okay? So here you have, and here these three ways represent the same. The numbers that are between -2 and 4, including the 4. So summarizing these three ideas for the notation, we can use set interval notation using parentheses to say something is open, and it's open when it's not included. When it's not included, okay, when you say that the value is less than, you don't say equal to. If you just say values less than 2, okay, you're saying values that are to the left of 2, but not including the 2. That's so important in mathematics, and especially in the set of numbers. Now, you have the other notation, the other part of the notation, which is use brackets when you have closed expression, and here is when you include the number. In set builder notation, you're gonna use for the open set, for the open values that are not included, the greater than or the less than. For values that are included, the greater than or equal to, or the less than or equal to. And in the number line, you practically here will show the main idea that is open, leaving like the space, like a little O, and close for O but shaded. Okay, so there you have the number line notation, the interval notation, and the elements for the set builder notation. Any questions? Is it clear the notations we will use or not? I mean, major questions, no problem. Three different ways to represent the same. That's practically what we have in here. Is it clear? One's working behind the principles of algebra, one's working behind the principles of just organize those expressions. Of course, a little observation. In interval notations, you're always gonna show the lesser value first and then the other one. Here I show negative infinite first because negative numbers are always lesser than positive ones, okay? And if you know, as much closer you are to 0 in the negative numbers, you become greater. So those are like basic ideas that born in this set notations, okay? Any questions? Estamos claros, pueden preguntar en español, pueden preguntar en inglés, no hay ningún problema, pero quiero que quedemos claros con esta primera parte, para luego ver las operaciones. Okay, if there's no question, let's see if you're clear or really get the idea. We have like 10 minutes, so I think we're gonna study the operations, the set operations on next class. So I need that you pick one of those exercises, okay? And represent this one in the notation that they are not represent. For example, the first one is an interval notation. So you already have like the answer of the third part, this one. That's the interval notation. I need that you write it then in number line notation and in set builder notation. Here you have numbers between. There's a little difference between between numbers between and numbers and going on. For example, if you just say less than 4, okay, the expression is x less than 4, simple like that. But here I'm saying that that value is greater than -2, but at the same time lesser than 5, to say that is between. So you have a way and an example in the last. Okay, I show you one example here. You have another about how can you write this one. If you already have an answer of those, share this one in the chat, please. And that way we probably can translate this answer here. Just try to use the same letter because the letter A represents the numbers between -2 and 5. The letter C represents the numbers that are lesser than 4, not the numbers between -infinite and 4, okay? This means be lesser than 4. And well, you have the other interval notations over there. Sorry, set builder notation over there. So let's see, if you have an answer, share this one in the chat, please. I'm gonna be checking the chat right now. The chat of the WhatsApp, okay, the WhatsApp chat. Because I think you can take the picture very quickly.
I can't see anything right now.
Oh, really?
Yeah, it's a black square over
And-
there.
And now?
Now it's better.
Okay.
Okay,
Yep.
it's like
Blurry.
Okay, who's ready with one answer to share it in the chat? We have like, oh, we didn't have enough time, but probably just to see at least like letter A, I mean, two of those exercises.
Mister, can you display the one that you just did before to see how to do this?
There he is.
Yeah, this.
Okay, time's running over. Remember, we finished today at 7. I think we're gonna start next class with this, no problem. And just wanna make a little observation. And it is related with something you're gonna do. So probably I'm gonna stop sharing right now. Yes. Let me show you what I'm talking about, okay? So we're gonna continue with this next class. If you have the answer, good. I will check it. I will translate it here to the Jamboard, to the open board, sorry, and we're gonna see what I'm talking about. Don't know if you're watching right now the classroom.
que no sé si, I don't know if it's my internet leak, but I see the board like frozen, freeze, like freeze.
Kind of blurred.
Yeah,
Yeah, freeze and
like a
blur.
blur. So I don't know what's going on.
Let's share again. So I'm sharing the classroom, okay? Don't know if you can see it now.
Yes.
Okay, here's a post.
It's really small letter.
The link for the Sunday class.
Oh, there you
Okay, yes, and what I need is that you access here, and you're gonna open a Google Docs over here, okay? You're gonna open a Google Docs, and on this Google, okay, I'm checking that some groups already shared the link. This is an invitation you're gonna make myself. It's not that I share my link. No, you're gonna share your link with me because I'm gonna be working with group 1, 2, 3, and 4. All of you, I mean, so good that you already prepared the meeting. And we're gonna do it following this schedule, okay? To show me how's it going, the project. That's gonna be it, okay? We're not gonna use more than the time I told you here. I prepare here just 30 minutes will be enough, I think so. Probably if you have some questions, we will extend those 10 minutes, but no problem. The idea is that we're gonna be following this schedule this Sunday, and that way you're gonna be like more clear to work on this. My only thing, or the only thing that I need is that you already define the area you're gonna work, the grade, the area, and you already define like the topic you will make the planning, okay? That's like the two main things I want or I need that you start, that you have it ready. And that way you can then start working. And if you already start working and wanna show me like the advance of the project, okay, will be good, because I think the last weekend we didn't have like many activities to do. And I think you have like part of the time. Remember that these classes start like 8 o'clock on Saturday and then goes until 5 o'clock. So then you're gonna have this time. We don't use all that time for the classes. Diana, you have a question? Do you have a question?
Yeah, I have a question. I'm watching this schedule. For example, I belong to group number 1. It's from 8 to 8:40. This means we are going to be presenting our project just to you or to all the class? I'm not clear on
No,
that.
this is just to me, okay?
Just to, oh, okay.
Yeah, just to me. That's why here I say, I will be with every group following the schedule. And if your group will be at 8 to 8:40, well, it's just group 1. Then I'm gonna be myself, not the classmates, just myself with the group 2 and so on, okay?
Okay, okay, I wasn't clear on that.
Okay, so do you get it?
Oh, and something else, we're just presenting you what we have. And I saw that the project was to be, or had to be uploaded on October 30th or 31st. I'm not
31st?
sure on the date.
Yeah,
So we uploaded on that date.
yeah, what I'm asking you right now is to already define 2 things, okay? The grade and the block you're gonna work, the area you're gonna work, and the class you're going to decide to make the planning. That's what I need, okay?
Okay.
Okay, yeah, so for this Sunday, at least this, if you have something else, okay, good, you can present that one. Well, it's already time, so sad. We're gonna continue with this representation of the stat notation on next class tomorrow. Tomorrow we're gonna have very interesting topics to study. Remember the schedule, we're gonna start at 9, from 9 to 10, then from 10 to 10:30, you're gonna have a break. And then from 10:30 to 11:30, we're gonna conclude the class, okay? So it's gonna be like this, following the schedule. So you're gonna receive the link again. I'm gonna send it tomorrow. And well, that's gonna be, it's already 7 o'clock. So thanks a lot for your participation. Try to place here the link for the meeting, okay? And well, have a good night and see you tomorrow. Question, sir?
A good night.
Night.
Yes, mister. Do you want the
Bye.
link only
Bye-bye.
through Zoom or Google Meet?
No, no, puede ser cualquiera, ahí es libre, ¿verdad? Y usted, por eso no puse aquí algo, solo puse una reunión, ¿verdad? Ahí nada más. No hay
Okay.
ningún problema, ¿sí?
Thank you.
Perfecto.
Good night.
Yo,
Ok.
I have,
buenas noches. Hola, ¿no escuché?
I have a question because I don't know if you read a message I wrote on the assignment number 1. Because I sent it, but I don't know if you received it because later on it appeared to me that it was not sent. So I don't-
Bueno, no sé. ¿Y quién mandó? ¿Tiene alguna
try
duda?
again.
Ok. ¿Pero que había alguna duda con la tarea o algo? ¿O qué pasó?
No,
Okay.
is that I sent the assignment, but the next day it appeared to me that it was not sent. So I don't know what happened.
Oh, no.
A
The
mí
thing-
igual me pasó eso.
No. Creo que eso es como trabaja Google Classroom. La misma duda tuvo un compañero de ustedes que me escribió. No es que yo les estoy regresando la tarea porque la hicieron mal o algo, la estoy regresando porque ya se la revisé, ¿verdad? Eso es lo que pasa con Google. O sea, Google a mí me notifica cuando ustedes me envían, Google Classroom, me notifica cuando ustedes me envían la tarea porque ya está lista para que yo la revise. Obviamente yo debo revisarla, calificarla, evaluarla y luego devolvérsela. Al devolvérselas, que ese es un pequeño detalle con Google Classroom, genera ese malentendido, pero vean que si yo se las devuelvo y ya tiene nota, es porque ya está evaluada. No es que la tienen que volver a enviar. Y vamos a estar en ese jueguito de envíamela que yo te la devuelvo. No, no vamos a estar en ese juego porque si no, entonces luego su nota no va, por así decirlo, no se va a guardar. Se guarda, pero se guarda como borrador. Entonces no se va a guardar después cuando haga yo la sumatoria final. Ahí sí les pido no estén devolviendo la tarea otra vez si ya la recibieron con nota. ¿Ok? Bueno, hoy sí.
Thank you, mister.
Thank you.
Bueno, nos vemos hasta mañana.
Bye. Thank you. Good night.
Good night. Bye bye.